Well, thank you, Scott, and thank you, Mary, for the invitation to speak. It's a pleasure to be here. I'd like to speak with you this morning about our use of design of experiments to develop a highly productive process for manufacture of a chimeric antibody in GS-CHO cells. And I was very interested in the first two talks this morning. Much of what I have to say is going to reference information that we learned both from Martin and from Scott. So this is, by way of outline, I'll talk first about the initial monoclonal antibody process that was the start of this work. And then the goals that we had were first to replace soy hydrolysate. The initial process was not chemically defined, and so our goal was to produce a chemically defined media. Second was to improve the titer, and the two efforts that we focused on there were composition and then dosage and timing. And then we were also interested in maintaining biochemical comparability from early process to improved process. And so I'll show you some data that we generated in manipulating the glycan distribution, specifically the galactose content of the antibody. And then part of this is going to be a demonstration of how we applied design of experiments, both in terms of factor screening and then level optimization. So the molecule on which we're focused here is a chimeric IgG1 monoclonal antibody. The cell line is GS-CHO, and the initial process gave us the following characteristics: a QP for the cell line of 10 picogram per cell day, and an integrated viable cell count of about 37 million cell days per mil. The process mode was fed batch with glucose as the component of the feed. The cell culture medium was a basal medium containing 10 grams per liter soy hydrolysate. And this set of conditions gave us a productivity for the antibody process of about a half gram per liter in a 17-day production phase. So those of you who are familiar with this kind of an antibody process, this is a very modest productivity in probably a longer process than one would like, and these numbers are modest as well. So our goal was to try to improve these threefold in terms of an increase of productivity in a shorter process. Our goal was to try to get to about 1.5 gram per liter in 14 days, to make no change in the basal medium, and to try to eliminate the soy hydrolysate in order to move to a chemically defined process. We wanted to maintain the oligosaccharide profile. And in the course of this work, we sought to develop a toolbox so that we could screen medium components to identify factors using DOE and a high-throughput culture system for screening and optimization. So we took advantage of the tube spin system that some of you may be familiar with. This is a system that has been pioneered by Florian Wurm at the EPFL in Switzerland.